So in this video, we'll be seeing about another clustering known as DBSCAN. So basically, clustering analysis is a unsupervised learning method that separates the data points into several specific bunch of groups such that the data points in the same group have similar properties and the data points in different groups have different properties. So that is a basic a recap of what exactly is clustering with respect to again unsupervised learning. So it comprises of many different techniques. Again, we saw about k-mean clustering and also hierarchical clustering. So now we'll be seeing about uh, DBSCAN. So basically, DBSCAN is centrally basically all clusters method uses the same approach. That is like we calculate the similarities, then we use it to cluster the data points into groups or batches. Here we will focus on the uh, uh, density based spatial clustering of application with noise. Okay, so that is the full form of what exactly DBSCAN means. So this is a clustering method. So again, before getting into deep exactly what is density based uh, clustering algorithm, why do we need this density based clustering algorithm like DBSCAN when we already have k-means clustering and all? Okay, so the reason is k-mean clustering may cluster loosely related observations together. Every observation becomes a part of some cluster eventually, even if the observations are scattered far in the vector space. Okay, so this can do arise with respect to k-mean clustering, and since the cluster depends on the mean value of the cluster elements, each data point plays a role in form of the clusters. So a slightly change in the data points might affect the clusters outcomings. So the problem is greatly reduced in DBSCAN due to the way of how clusters are formed, which we'll be seeing in a minute. So this is not usually the big problem unless we come across some odd shape. Okay, so when you're coming across the data set is a kind of odd shape, so at that scenario you can go with density uh, based clustering like DBSCAN. Else you can stick with k-means if it is giving another giving the required or a very good accuracy. Okay, so another challenge with k-means is that we need to specify the number of clusters in order to use them. So again, here also we don't need to specify with respect to any number of uh, clusters that need to be specified, just like how we saw with respect to hierarchical clustering. Okay, so again, what is good about DBSCAN is that you don't need to specify the number of clusters, and all we need to do is function to calculate distance between the values and some guidance for what amount of distance is considered to be close. Okay, so again, DBSCAN will produce reasonable results than k-means across uh, based on different distributions. So again, we will uh, see what exactly it is. So basically, DBSCAN is density-based clustering, again referring to an supervised learning method that identifies uh, distinctive groups or clusters in the data based on the idea that the clusters in data space is contiguous region. Okay, so the data space is a contiguous region of high points density. Okay, since and separated from each separated from other clusters for contiguous region of lower point density. Okay, so that is how the uh, clustering will happen or the grouping will take place. And density based spatial cluster of application with noise. Okay, so that is the complete acronym. Okay, so density based spatial clustering of application with noise. Okay, is a base algorithm for density based cluster. So here we are dealing with noise, so while containing noise, so basically it can discover clusters of different sizes, shapes from large amount of data which is containing with noise. So basically these noise can be considered as outliers. So we have already seen the concept of outliers, right? So basically these outliers will be considered as noise. So to like prevent those, like basically to handle such outliers only, we are going with density based spatial clustering. And here we have two main parameters which we need to see with respect to DBSCAN algorithm. So the first one is minimum points. So the minimum number of points, or it can be considered as a threshold, are clustered together for a region to be considered as dense. Okay, so then only it is be considered as dense. And next is epics. So eps, epsilon, something like that. The symbol is like that. F's. Okay. So a distance measure that will be used to locate the points in the neighborhood at any point of any point. Okay. So again, these can be understood if we explore two more concepts called as density reachability and density connectivity. So what exactly those terms are? Density reachability is a term of density establishes a point to be reachable from another if it tries to lie within a particular distance. So that distance will be f from it. Okay, so basically this is the reachability, like from one point to another point if it lies within the particular distance. Okay, so that is the distance what we had just mentioned, right? F's. Okay, and next is connectivity. So basically connectivity on the other hand, it involves a uh, transitivity based chaining approach to determine whether the points are located in particular cluster. Okay, so maybe we can consider example points like P, and Q are connected, so they can be connected from P, R, S, T, Q. Okay, so R, S, T are the points which are in middle. So here it means like the points next to each other, like P and R will be the neighborhood. Okay, so again with respect to the types of points after DBSCAN cluster. Okay, so what kind of types of points we can consider? So basically there are three: core, border, and noise. Okay, so on the right hand side you can see the image of what exactly are the points. So you can see the core point is usually at the middle. So this can be considered, the core is nothing but similar to centroid. So we have already seen about centroids, right? When it comes to classification and all. So centroids and also clustering also. And with respect to that is the core, so this is a point that has at least m points within the distance n from itself. Okay, so it will have at least m number of points. So again, what is the m number of points? So this is the minimum points which we saw earlier. And the border. Okay, so here the border is a point that has at least one core point at a distance of n. Okay, so it should have at least one core point, so that will be considered as a border point. So here we can see with respect to black dots. Okay, so those are all the border points. And finally the noise. So these points, that is neither a core nor a border, so it has less than m points within the distance of n from itself. Okay, so basically it is the noise point, so which is like kind of the outliers. Okay, and also here on the right hand side the minimum points is 3. Okay, so that is what is been mentioned over here. So that will be our final outcome with respect to DBSCAN. And also we have the algorithm steps. Okay, we'll walk through with respect to the algorithmic steps for DBSCAN. It is again quite simple and very few steps. So basically the algorithm proceeds by arbitrarily picking up a point in the data set until all points have been visited. Okay, so it will be going from one point to another. Okay, so I think you are getting the idea how exactly it is done. And if there are at least minimum number of points with the radius of epsilon to the point, then we consider these all points to be of the same cluster. Okay, and then you can move on to creating the next cluster. So that is basically the clusters are expanded by recursively by repeating the neighborhood calculation from each neighboring point. So that is how it has been done. And these are the steps again with respect to parameter estimations. So each data mining task has a problem of parameters. So here every parameter is influences the algorithm in the specific way. So here the two main parameters are epsilon and minimum points are needed. So basically for minimum points, as a thumb rule, a minimum points can be derived from the number of dimensions, so D in data set, so which has to be greater than like minimum point should be greater than or equal to D plus 1. Okay, so number of dimensions what you will be using. the low value like minimum points can be equal to 1 does not make any sense. Okay, so we cannot have 1, so there should be at least 2. Okay, so as every point on its own will be already a cluster if you consider minimum points as 1. So within like if the minimum points is lesser than or 2, the result might be same as similar to hierarchical clustering with a single link. Okay, so it is not many links clustering with just a one single link. So with a dendrogram can be cut at a height of epsilon. Okay, so therefore minimum points chosen should be at least 3. So however, the larger value are usually better for the data set with noises and will yield more significant clusters. So again, as telling the thumb rule, so minimum point should be like at least we will be having 2 dimensions. So 2 dimensions can be used, and d plus 1, so that will be 3. Okay, so 3. So minimum point should be greater than 3 plus 1. Great. At least 3 can be used, but it may be necessary to choose larger value also for larger data, and for noisy data, for that the data that can contain many duplicates. Okay, and that is about the minimum points this parameter. And with respect to epsilon, so the value of epsilon or eps, okay, eps, so f it is actually epsilon is the capital letter and this is the small letter, the symbol which we had seen. So here epsilon can be chosen similarly by using the k distance graph. Okay, so basically the k distance is nothing but minimum points minus 1 nearest neighbor order. So from the largest value to the smallest. So good value of epsilon will be where exactly the plot shows the elbow method, okay, which we had already seen. So if the epsilon is chosen too small, a large part of the distance will not be clustered. Okay, so large part of the data will be missing as noise points. So whereas too high also will have the clusters to be merged, and majority of the objects will be lying in the same cluster. Okay, so in general, small values are preferable, as the again considering the rule of thumb. Only small fraction of points should be within the distance of each other. Okay, so it should not be more also. And with respect to the distance function, considering the distance function, the choice of distance function is tightly linked to the choice of epsilon, and has a major impact on the outcomes. Okay, so in general, it will be necessary to identify a reasonable measure of similarities for the data set, because the parameter f can be chosen and there is no estimation for for this parameter. Okay, so but this is the distance function needs to be chosen appropriately for the data set. So that is about DBSCAN, and also a quick fact about DBS. Okay, DBSCAN, or in 2014, DBSCAN algorithm was awarded the Test of Time award. So basically an award given to the algorithm which is received substantial attention in theory and also in practice. So at the leading data mining conference. Okay, so that's all about DBSCAN.